Okay, well, we did have a different talk scheduled for this hour time slot. Similar topic. It was going to be a deep dive of running databases in containers. Because of that last minute change, I want to thank everybody that did join this panel discussion on this topic. It was a very last minute change, and we kind of got resources from all over the world that I'm really excited to have talk about this really exciting topic, because it's something that we see in the market. Everyone is shifting more towards either containers themselves or orchestrated containers in something like Kubernetes, with Nomad, with pick your poison. We're seeing people starting to gravitate more and more towards a container type of deployment. And what does that mean for databases? And especially, what does that mean for running databases inside of those containers? So I want to introduce our panelists, and I'm just going to go around kind of top to bottom and let them introduce themselves. So a panelist, take it away.
Hi, I'm Gabby. I am a developer advocate for Google Cloud. I was a data engineer before, and I mostly work with MySQL and Postgres.
Thanks for coming.
Hi, I'm Andre. I work at Arista Networks. We build switches, and I work on the telemetry part, storing all the metrics from all the switches in the data center into our system. And primarily, I work with HDFS, HBase, and Kafka.
Thank you.
Hi, my name is Deepthi Sigareddy. I'm a software engineer at PlanetScale. I'm also a maintainer of Vitis, which is an open source sharding scaling system for MySQL.
Great.
Hello. Okay. Hello, I'm Tanix. I'm Shuanden, and I'm from PingCap company, the company that developed the TiDB database, the distributed NewSQL database, and TiKV, the CNCF project, and also the Chaos Mesh. I'm the cloud engineer, not leading the TiDB cloud product.
Thank you.
Hi, everyone. I'm Yelei. Same as Tanix, I also worked at PingCap, and now I'm working on developing the infrastructure of our managed database service, the TiDB Cloud, and I'm interested in all stuff about Kubernetes and containers. Thank you.
Great. So I think with this, we're going to have all kinds of different opinions, because we're not just in one type of ecosystem. It's not like we're just looking at NoSQL in containers. We're not just looking at, analytics workloads in containers. We're not just looking at, raw databases in containers. We're looking at distributed storage. And so I think we've got a pretty good group here to really talk through some questions that we prepared. And the first of those I really want to ask and put forward to the panel is, what do containers mean to you, and you in your role, and you at your company? And so I'll kind of open it up, and if nobody talks, I'll start calling on some people. Looks like we have our first taker, Deepthi.
So as an engineer, what containers give me is less worrying about build environments. So the environment on which we are building Vitis binaries, for instance, are predictable rather than all over the place. And the dependencies are predictable, and we deal with those at build time rather than at runtime.
Good. And so you're saying, from a containers and what they mean to you is really you can rely on that build the same way in your development environment as if someone else that isn't you deploys that thing. You can rely on that to fundamentally be the same thing.
Exactly. And at PlanetScale, we are running both MySQL and Vitis in Kubernetes. So we are running all of those under Docker, and we are able to avoid many of the issues you run into with infrastructure that can change under you. The container builds essentially give us immutable infrastructure that we can rely on.
Good. Gabby, you said you came off mute, so I'm going to let you
No, I
go
didn't
next.
say it. I was just agreeing with her.
Yeah.
No, I think it's as she said, it's like deterministic, you know, like when you do a query that's deterministic and non-deterministic, you kind of, every time you follow the same steps, you can expect the same result. So it gives you more security for some things. The container itself, I see as a recipe, in my opinion, for something that you're going to be using over and over, as DPT said. I think they can get tricky, you know, on the end, if you have stateful things, volumes attaching to it, that's where it starts the rabbit hole. But I don't see it as a bad thing. I think they're good. I just think it needs, people are right now putting too much, like, I don't know the word in English, sorry for that, but like we would say banalizing the use of it, like using for everything. And sometimes you don't need to use it for everything, you know?
Yeah, and so just to boil that down, you think containers as a fit for purpose use case, in that fit for purpose that we're talking about, immutable from a software perspective, and kind of being that layer that you can depend on for that immutability, that isn't something that you should just do globally. All right, you should approach that with caution.
Yeah.
Great. Do we have
Yeah.
from Tanix?
Yeah. To me, the container is a kind of a packaging system that runs across all Linux distributions. And it's also a virtualization technique that helps us to manage software and service. We can run containers in different virtualization level. It's more flexible than traditional VM, and many scenarios don't need fully virtualization, in my opinion.
Yeah, and you bring up an interesting point on the flexibility with containers, and so I want to dig into that a little bit more. Do you mean flexibility from resource availability? I think most of us have been around long enough to know whatever hypervisor you're using to deploy virtual machines, in order to change the resources that virtual machine has access to, you need to oftentimes restart that virtual machine. Is that the flexibility that you're referring to with containers?
Yes, the resource isolation. Not all kinds of services need a fully isolated environments, because the deeper the isolation, the more overhead it brings. So, for example, in the company that some services share the resources that we can make most of the hardware without the fully virtualization.
That's a really good point. Andre, you came off of me.
I guess most of those things that were already above said is determinism, isolation, all of that, and having reproducible environments. Like I can pull in the image, same exact image is used for tests. It runs on bare metal. In our on-prem solution, it runs in the cloud, the same exact image. And all of that, to me and to my company, it all saves a lot of time. I don't need to worry about setting up environments. It also, as it was already mentioned, that it saves time also in terms of startup, because you don't need to spin up entire VM and wait until it boots up entire OS inside of it. And it's just productivity on all fronts.
Yeah, and I want to ask you a question, just because some people may not be familiar with the scale that you operate. At what point does that scale start to really tip the scales when it talks about containerization, right? Saving time, when you're saving 30 seconds one time a month, is much different than when you're saving 30 seconds 10,000 times a day. And so how does that play into kind of what you just added to the panel?
I guess here it's more of a orchestration part of it that saves, I guess, because containers are so fast and lightweight to start up, it also makes our on scale, what matters there is how fast you can recover from failures. When the VM goes down or an entire host goes down, it's a matter of seconds that container is going to be spun up somewhere else in some different nodes. So we have a much faster recovery from downtime. So that's something that can be felt. And in terms of productivity, well, when you have like 100 engineers working, and instead of them waiting every time for a VM to start up, you wait. They can spin up a container with the same exact environment on their local host and run a test instead of that. So, yeah.
Not all really good points. Yele, I want to. You're last on this one. So, anything you'd like to add?
Yeah, so we've all talked about that container saves us a lot of time, and it's immutable, it's predictable, it's lightweight, and it's portable. Now, I also think containers open a door of the orchestration system for me, because container is so lightweight and predictable. So I think it is a perfect unit to be orchestrated. So we can see that Docker Swarm, Kubernetes, and HashiCorp, Nomad, a lot of orchestration systems are flourished in the container ecosystem. And then we got a lot of automation in our deployment and operations, and we can write the extensions like operators, customize the controllers to automate the daily operations of our database, and finally to greatly reduce the human toils in operating database. But not only increase this, it also increases the stability because there's less room for human errors.
Yeah, and I like that you added that, because it really, for me at least, brings back the Lego analogy that a lot of people use for containers, where you have an expected result. A 4-prong Lego or a 6-prong Lego or an 8-prong Lego are always that, right? And you know, if you built a machine that knew how to put Legos together, it would just build them according to those rules, instead of some amorphic thing that maybe you can stamp out some stuff with silly putty, or something that's a bit more amorphic and customizable to get exactly what you want. But the automation, you can't re-engineer a machine to do that every single time, or that machine would be much more expensive and much more sophisticated than something that just knows how to grab 4, 6, 8 peg Legos and slap them together according to an image.
Yes, exactly. Impressive summarization.
Great. I think that answers, I think, what containers mean to everybody on the panel. And I want to move into kind of the next phase of the discussion and talk about when we think prime time is for databases and containers. I think that it's pretty obvious that everybody here thinks in some way, shape, or form that containerization, especially when it comes to databases, is appropriate sometimes. When do we think that that's going to be kind of the leading way or the primary way for people to start looking at a deployment methodology when they're running databases in containers? And so I'll open that up to the panel again. Yele, if you want to start off. Or anybody else.
So I don't have a hard line to say when it's the prime time. What I can talk about is a bit of the evolution of what you see on, because as people say, like most people here talk about containers, but they also talk about orchestration, you know? So like it's the container by itself, it's useful, but like if you can't orchestrate it, you can't have that ease of mind, you know, like, oh, it's going to restart if it fails or that kind of stuff. So the thing is, I think it depends a lot on the kind of database you're running. Like if we're talking about like a relational database, let's assume rule of the thumb, I'm going to write in sand, not a carve on wood. It's not made to go horizontal by default. There is horizontally scalable relational database. It's not the standard case. Whereas when you go to a NoSQL database, you can kind of assume that's more easily achieved. So when you get graph databases or MongoDB or that kind of stuff, it's like, I think they're ready to be on a container aspect right now. And the relational databases, there is, I'm looking at the Slack here, someone asked, like, how do you run containers in Kubernetes relational databases? Because let's think about index warmup, you know, like the pods are, if orchestrated, or you can't rely on their life cycle. You know, you don't know when it's going to be shut down, and you don't know why it was shut down. Something maybe gone wrong. And then what happened if that index was all cached in memory? You know, you lose performance in the end, you know. So I think it's not there yet, but I could be wrong. Please, people chime in. But like my personal experience with that, it's like if you're just doing your own MySQL database without being like Vitas or the things like that, just be careful, you know, because you may actually lose performance and not gain performance on that, you know.
Yeah, and I think that's a really good point. Yeah, Deepthi definitely has something to say about this.
Yeah, sorry, Deep. Please correct me.
No. I have to agree that we don't seem to be quite there yet in terms of running databases in containers, and an orchestration layer is definitely a must, because you do have to deal with the sort of complex restore scenarios that the question in Slack was just about. But what we do also know is that various players have started building Kubernetes operators for various different databases, whether it's MongoDB or Postgres or MySQL. We now have Kubernetes operators coming out that can be used to run these databases in Kubernetes specifically as the orchestration layer. And but still, it is fairly early, and it's the early adopters who are trying this out at this point. And beyond the operator, you probably need something else like Vitess for MySQL or Citus for Postgres to be able to deal with the pod is taken down by Kubernetes, or pod is rescheduled on a different node. How do you recover from that? How do you deal with the cold cache kind of issues? So all of those become relevant when you're thinking about databases in Kubernetes.
Yeah, and I think you two have brought up a pretty interesting point, specifically from kind of the RDBMS world and how much it's reliant on cache, and you know how chaos can play into bad performance. And I know several other talks at Percona Live have really said, you know, at scale, what really makes databases scale is this in-memory cache, right? And using that and tuning for it and making sure that works appropriately. And so it's interesting to see some of the old world before this was even a paradigm, right? Before containers existed, MySQL's been around, right? Before containers existed, Postgres has been around. Even Citus was around before containers. You know, you can't say as much about Vitess, right? I think that came out of, you know, necessity and Borg, but it's a really interesting question that's being posed here from kind of legacy systems that didn't have any awareness of this deployment pattern. But what about some of the things that came about after this was kind of a known and well understood deployment pattern? some of the databases, that could be coined NewSQL or NoSQL even in the last couple of years that have picked up steam. And I think, the guys from PingCap may have something that they want to add here.
Yes. We run TiDB databases on Kubernetes very well. TiDB is the so-called NewSQL database. It's a distributed database that can be scaled horizontally, nearly unlimitedly. So it's not like the traditional database that can only scale vertically. So we can write our operators, the TiDB operator, to run the TiDB database on the Kubernetes clusters. It's easy to scale without downtime. Yeah, and we can also write our own operation logic to automate the management of the TiDB cluster. So I think both technologies are evolving. The container technology and the database are both evolving. When they reach a time that they cooperate well with each other, then it's a prime time for database in containers.
Yeah, and so do you think we're getting closer and closer to that with something like TiDB that is, from a paradigm perspective, being actively developed in this new world where everything is smaller pieces? Or do you think that there's still kind of a long way to go from both sides with the database and the containerization side?
Yes. I believe more and more databases will have a more cloud native architecture to embrace the Kubernetes technology and the cloud technology.
Andre?
Just to add a bit to what he said on the Deepti said, and what Xuan, right, said?
Yeah, you can call me Tanix.
Tanix, sorry, Tanix. The horizontally scalability of a cluster, because 2 years ago when I started learning Kubernetes, like you couldn't have different regions on a cluster, it was a limitation. Right now it's not. And like when I say like databases built the technology from 1970s, like if you stop to think about it, and like this is Kubernetes thing changes very fast. So, and like there's a catch up to get there, the databases development needs to catch up to the speed of Kubernetes, or the Kubernetes needs to slow down a bit more. I don't know what's need to happen first, but like we do have managed databases, and if you stop to think about it, they are running on containers, all like from other cloud providers. In the end, they are running on containers. They are managed, but they are running on containers, and there are of course investment on the background, to keep that running and not die at any time on you. But the thing is that someone also posted there is like some capabilities that like backup, point in time recovery, all those technologies that came after, and not after, that are built in on the traditional relational databases. And how, I don't know how PingCap does it. I would like to know this part of the technology. How do you envision implementing on an orchestrated world, Tanix?
For the point-in-time recovery, we will embrace the cloud technology, such as the AWS, the S3 object store. So we can take the backup almost synchronously into the S3 bucket Yeah. So we can have local cache with the local storage, and for the code data, we can store it in the S3 bucket. It's the tiered storage layer.
Great.
Gabby made a, sorry, Rick.
Yeah,
I just
you're
had
fine.
a follow-up comment on what Gabby said. I think Gabby made a great point about Kubernetes and the databases needing to work together, because Kubernetes and other orchestration platforms bring something to the table in terms of running databases in a more reliable way, but they do need some functionality on the database side to make this happen, so that Kubernetes is able to reschedule a pod and the system still stays up and continues to work as expected. And she's absolutely right that that part is moving much more slowly than the pace at which Kubernetes is changing. And that's really why something like Vitess even needed to exist, because you could not have vanilla MySQL work in Kubernetes, say 5 years ago. It's closer to that now. I'm not qualified to comment on whether it is fully there yet, but I can see that there's movement in that direction.
Yeah, that's right.
Andre, you've come off mute a few times. You're chomping at the bit to get something out.
Yeah, I just kind of wanted to say both hear those good really points. From my experience, I'm kind of in between here, because HBase came out in 2010, so it's like before Docker and before Kubernetes. Of course, we were one of the first people that actually put HBase on Kubernetes, and there's been a lot of small issues still going on, like especially with networking in HDFS. Like, it's all meant for bare metal. It's meant to have a stable IP, and then a pod restarts, and then it has completely different IP every time. So there's a lot of small issues that have been still are happening. Like, for example, now we need to provision a servers per pod, and that makes it not as easily to scale. But right now, what we've settled actually, and I've started doing this actually only recently, is writing Kubernetes operator for HBase. There is a lot of work there that needs to be done. But that work can be easily automated. Like, while before, for example, I had to go into each of the region servers, so these are the worker nodes of HBase, and go and drain all the regions from it by essentially calling command on it. Now I can just say, Kubernetes, okay, here's a new version of config map, go restart each pod for me and drain it prior to that. So it's kind of nice that all of that work needs to happen from outside of HBase. Like, HBase doesn't even know it needs, it runs in Kubernetes. And it's kind of nice fit there, but there is still a lot of small things that even just because it's Java, like, for example, caching of DNS, things like that, that needs to catch up to that for it to be actually useful. So yeah, from my experience, it would be nice to start developing, if any new databases that come out actually fully embrace Kubernetes. Like, for example, they use leader election that is built in Kubernetes. That removes the leader. You don't need a leader anymore to decide on what to do, and the Kubernetes operator could be the leader to decide of how to balance around the regions and things like that. So yeah.
Yeah, and we've talked a bit loosely. I don't want to transition this to operator talk, but we have talked a bit, we talk a lot about Kubernetes. It's kind of the leader right now in the container orchestration space. It's far and away more adopted than something like Swarm or something like Nomad. So I think that's why it keeps coming up. But and operators, for those who may not be really familiar with the Kubernetes space, essentially are an extension to Kubernetes that allows you to control some type of stateful set or stateless set that to do operations that a human would have otherwise had to do. So now no logging into containers to do, configs, no draining, right? You have the operator do that, and it does it the same way every time across the entire infrastructure. And so with the introduction of operators, is that kind of Kubernetes attempt, or right, container orchestration in general's attempt to get closer to the database? And we haven't necessarily seen a reciprocating, oh, we're going to do things like replicate what's in memory instead of just replicating data from the database side. So are we not seeing kind of the database side make the strides forward to having some of this play nice together? And I think you brought it up really great, Andre, where you said HBase doesn't even know it's running in Kubernetes. Is that really the sticking point that keeps databases in containers from being prime time? So kind of shifting the question a little bit as we go.
It's definitely a constraint. It's probably holding people back a little bit to have to find an operator that they can use when they start trying to run their databases in an orchestration system. But having said that, as of now, it seems to be possible to bridge the gap by using operators. But of course, it will be possible to squeeze out more performance, make things more reliable if there were the reciprocation from the database side. And here, obviously, I'm talking about the databases that came before the container era and not something like TiDB, which was built with running in a distributed system in mind.
Yeah. Gayle, do you have anything you want to add before we potentially move on to the next question?
Yeah, actually, I want to continue the, first, I totally agree with Andrew that I think the prime time is mostly depends on the database itself, because there are lots of low-hanging fruits in Kubernetes for your database, like automated rolling updates, like version managing, like horizontal scaling. But the price is that your database has to tolerate some traits of Kubernetes. It's like maybe your instance, your container will be, your pod will be restarted anytime sooner or later by Kubernetes. And you have to tolerate that your pod IP may change, your pod may be recreated and be created in another machine. And if and if the database can tolerate all these traits and in return leverage these traits to empower the database itself, like TiDB, it can leverage the immutable the trait of Kubernetes pod to perform automatically failover, then it's a good fit on Kubernetes. So I think for TiDB, it's already the prime time. And for some traditional databases, we still need more works from the Kubernetes side, also the database side, to make each other to fit them more seamlessly. And for the operator, I think operator does not add more constraint to people to adopt database on Kubernetes, because operators simply add more database and domain-specific language, the domain-specific knowledge of your database. Without operator, you can simply spin up a database, literally any database like TiDB or CockroachDB or MongoDB, MySQL on Kubernetes. You simply don't get the extra functionalities provided by the operator, like automatically adding replicas or scheduled managed backups. And actually it's a trade-off. If you want to learn the operator and accept the compatibility, and you can get lots of automated primitives and the knowledge is programmed by the operator author. And if you just want to spin up a simple cluster and you don't need that much functionalities, it's also a good fit. Yeah.
Yeah, and I think you made a really interesting point that, and I'm assuming that containerization and Kubernetes, maybe Swarm or Nomad, are actually the preferred methods of deployment for TiDB from what I'm gathering. Or are you still saying that it's the preferred method to kind of do it on VMs or a mix?
Yes, deploying to our orchestration system is a preferred deployment model for TiDB.
See, and that's interesting because that's distinctly unique from the traditional world, where it would be considered newfangled, right, and exploratory or bleeding edge. Where with you, it's like, well, that's kind of table stakes, and if you want to run it outside containers, you can too. Which is it's an interesting. I'm really glad you stated that, because saying that it's prime time for some and not for others, and really solidifying why you think it's prime time for TiDB, I think has added some clarity to this question.
Thank you.
All right, we're doing pretty good on time though. Well, we're 40 minutes through here. We've only gotten 2 questions down. So I think we're doing pretty good on thought leadership here. So what's this? Now we start getting into fun stuff. Story mode. So what's the most dangerous thing you've personally seen with the interaction from containers and databases? What disaster scenarios have you seen? What kind of unrecoverable blast radius have you seen? These types of stories, I think, will help enlighten our audience to some of the caution that they should proceed with in the containerized world, or just some of the gotchas that they need to watch out for. Tanix, you got a grin on your face. So do you have a good story?
Yeah, we've started the TiDB operator 4 years ago. About 4 years ago, that the etcd, the CoreOS announces its etcd operator, and at that time, there's no local persistent volume in Kubernetes, and also I remember that the stateful set is still called pad set, and so to run TiDB in Kubernetes, we have implemented a local persistent volume based on the host path. Actually the community local persistent volume came out at 1.7, as I remember correctly. So we've have our own homemade local persistent volume, but this local persistent volume is coupled with the TiKV store, TiKV raft store management. So we have we're very excited about the operator pattern, and we write everything as automatically as possible. Then we've met that there's a corner case that we were not aware of. So when the bug was triggered by an accident, our operator deleted the volume one by one, then got our database cannot be recovered. So that is most dangerous thing I've personally seen.
So that sounds like, watching a train wreck in slow motion, where once it's started, you can't really do anything to stop that orchestration and automation. So just to kind of summarize, what happened there is sometimes these corner cases can present themselves in interesting ways that nobody really thought, that have massive and drastic consequences that aren't just immediate, right? They happen over time, but because of the automation, they also happen quickly over that amount of time.
Yes. Yeah. From that from that time on, we have redesigned our operator to do conservative operations. Only do conservative operations that leave the dangerous thing, the deletion, to be confirmed by humans. Yeah, until we are 100% confident about this will work like this. So beyond that, we will leave the deletion to humans. Reconfirmation, confirm. Yeah, I believe the Kubernetes persistence volume is also the same design. That it's the lifecycle management is different from the pod, and when we delete a pod, the PVC will not be deleted, and if we delete a PVC, the PV can, if we set the PV reclaiming policy to retain, then the PV will not be deleted. So the data is still there. So we embrace the same design.
And so essentially the primitive doesn't delete the data, it just removes the attachment to that data. So it just stays there, but you've got to go clean it up yourself, or have some other job that goes and cleans up disconnected PVs from the PVCs.
Yeah,
interesting.
That is must be confirmed by humans.
Andre?
It's just such a deja vu. We didn't have a Kubernetes operator. We just put HBase, and we just put, actually, was data nodes of HDFS on Kubernetes, and it was our prod. One of the upgrade, and we used to use there used to be no like, you couldn't mount volumes because we were running on bare metal. You could mount only one PV per pod, and you couldn't mount multiple pods. So what we hack around that was that we would put one host path into the pod, and the rest, we had to mount 8 volumes. 7 of them were host paths. 1 of them was PV. At some point, we had to upgrade our worker nodes of Kubernetes, and for whatever reason, that upgrade ended up deleting every 1 volume out of all the 8 volumes on each node. So basically, it was like a distributed RM-ref on one of the volumes, just because of some upgrade in Kubernetes. And basically, we didn't even do anything wrong. We just relied on Kubernetes here. I have an issue here open if anyone is interested. They fixed it pretty fast. The funny part about it was the function name was called maybe it's a root drive, and basically that it was a heuristic, and they misjudged that it was not a root drive, and ended up deleting the volume, and we couldn't actually recover any data. We just had to apologize to customers saying we lost your data. So now we do backups.
Wow. Yeah, and so that's a pretty distinctly different problem, I think, that's presenting itself, because you're relying on the Kubernetes primitive to behave in a certain way. And because of that heuristic being a little bit off, even it wasn't behaving the way that it was intended to. And so some of this new territory comes with, hey, how much can you really trust the actual Kubernetes primitives whenever you're doing these operations that could have lasting and damaging effects to persistent data systems, right? If you were in a stateless set, irrelevant, right? Mostly because you would just spin up a new pod and then it's all hunky-dory, right? That one's no longer good and you just spin up a new one and that one's good. So that's actually a really interesting addition.
So that just sound like, oh, now we do backups. You gotta remember, it wasn't a container disaster, and it wasn't with me. But I do remember postmortem that GitLab did, and I found that really nice that they did a public postmortem on it. They had an issue with Postgres. I don't recall what the issue was specifically. They were doing backups. There was a problem though. Doing backups is just not enough. You need to test the backup. So like, yeah, they tried to restore. It didn't work. And like they lost a bit of data there. And so I can link here on the Slack channel to the blog post for there. Like, it's not like, I admire all of you to trust Kubernetes that much because like I don't. I don't trust now because like it's too new, it evolves too fast, and as I said, like it's a race between databases and Kubernetes. It's not against with each other. It's just like people have different goals, and like that's why I like, even though I know that if you get Amazon, Google Cloud, or Azure, all of their managed database services do runs on containers. But like, if you are running on a container, please do backups, and also do an automation to see if the restore works, because like if it doesn't work, what's the point of the backup, like it's complicated, and tools fail because they're built by humans, and that's gonna happen, and like it's like that I don't know if you saw on Twitter, someone posted a C++ code, and anyway, on a compiler it returned a value and another one returned a different. And the kick was there was a backslash before. So and both of them are right, but you even though you have a strict set of instructions, you don't know what could happen sometimes, so yeah, that's a good cautionary tale, Andrew. I like that.
So my story is more to do with infrastructure. As easy as it is to spin up infrastructure in the cloud these days, it's also equally easy to delete your infrastructure, and that's what happened to us. But luckily, this was before any of our users were actually using it live in production. It was still in beta, so it was not a disaster. But since then, the usual lessons apply. You want to lock down access to your production environments. And because we were in testing, it was not yet locked down. And you do want to think through some of these things, as many as you can. Of course, you can't think of everything. And now we automatically schedule backups. Each time we do a new backup, we restore from the old one, make sure that the restored instance can catch up to the current primary before we take a new backup. So some of these things that the panel is talking about sound really familiar. And definitely Kubernetes started as something that solved the stateless problem first, because that was an easier problem to solve than the stateful problem. And now we are at the point where literally thousands of people are trying to solve the stateful workloads in Kubernetes problem. And persistent disks and persistent volumes are still relatively new. And so I think we see that all of us are trying to build safeguards around them, rather than just trusting that things will work as advertised.
Great. Yale, did you have anything?
My story goes that typically we think the container is stable because it's barely processed with some isolated namespaces and maybe C group limits, and both of them are better tested. But actually, we've encountered our critical issues caused by C group KMEM accounting. The story goes that we tested our database performance on Kubernetes, and there's a heavy read-write load on the disk. But the disk I/O performance just occasionally jittered. After weeks of diagnosing, we finally found that there's a bug when processing the KMEM limits in the Linux kernel. And if I recall correctly, the version should be 3.10. And it's also caused by runc, which is the command line tool used by Docker effectively, because that version of runc will add a KMEM C group limit for the container process by default. Even if the caller didn't add any KMEM limits, it will add it by default. And at the Linux kernel 3.10, the KMEM accounting is not stable. As I said, it has a bug that may cause the I/O performance jitter, and the database is literally not usable. And so I'm impressed by this issue because not only because such issues are really hard to diagnose, but also it reminds me that the thing that we think stable is not always stable. And the only thing can save us is to test our database in certain infrastructure thoroughly by heavy load, maybe by chaos. Anyway, test it from bottom to up.
Yeah, and I think you make a really good point that what we once thought was stable ground has turned to quicksand with this new paradigm. It's something truly different and new. And even though you're in a place that you know everything about it, you probably actually don't, because this has introduced a wrinkle that really no one ever thought about before. I usually don't participate in my own questions when I host a panel, but I think I want to in this case, because one of the things to me that I've seen happen is when something that is good gets so good that it's bad. And having a runaway scaling problem in containerized worlds, like we said earlier, everything gets so easy to deploy. And an example that I have of this actually just happened to us at Percona, where we have our alpha build that was released internally for our database as a service offering that I think Peter's talked about with our Percona Enterprise platform. And what happened there is it's so easy your grandma could do it. So even some of those who know Ann Schlemmer, our GM, is a very, very non-technical resource. Even she was able to kind of deploy a Kubernetes cluster. So what happens when you have 250 people, most of them technical, saying, oh, I want to try this and maybe spin up 3 or 4 or 5 clusters? Well, what happens is you spin up like 5,000 clusters. And that can get really expensive really fast. And the same way that gets really expensive really fast for us at Percona, and the story that I can tell that's pretty funny because we caught it early, is maybe not so funny to a company who isn't doing R&D and is running maybe an analytics query that they needed an answer for, and it relies on some horizontal or vertical scaling. But at what point do you say, wow, that container scaled up to consume every resource on a 24x large container times 10, and I got the answer in 1 minute instead of a 1 day, and I needed the answer tomorrow, and that query ends up costing you $40,000 instead of $400. And I think that's something that I've personally seen some of these runaway trains that can happen with containers, not necessarily just through the orchestration, but just containers themselves lend themselves very easy to the scale by credit card danger, where all of a sudden you look up and you do an audit and it was so easy to have all these containers that now you just have way more containers than you thought that you needed, right? And so it's the inverse of the density problem. Now you have really high density, but way too many things. So that's my addition there.
Yeah, charity
and we
for Google. Sorry.
What was that?
Charity for AWS and Google.
Yeah, I'm sure they. I'm sure
I do have
I
do have a fun story about that, because like internally I can test Google stuff. So people ask me how much it costs. I was like, I don't know. Just I never see the bill. But like there was someone in my team that was if you don't know, we do have a horizontally it's not open source database. So it's called Spanner. It's horizontally scalable. But the thing is, the person ended up with a bill of $300,000 and like 3 hours, you know. And it was like the team was like, what you doing? It wasn't me, but like that was like, okay. And then I started paying attention to my bills and set thresholds, you know, because I don't want to get fired over that.
Yeah, and so I think it's twofold, right? I think too much of anything, right, even if it's good, can be bad. But then these caveats that everybody's kind of laid out for this is new territory, even for people that are expecting solid things from the Linux kernel that right is ancient, right, and has been in CentOS 7 forever, right? We still can't depend on that Linux kernel because this is so new. And we're coming up on time, and I had a few more questions. I think this was a really great use of an hour, and I think we could have gone for a lot more time with this group of people. But I want to take this time to say thanks, and then go around the room and let everybody give some final thoughts or some parting knowledge to some of those people that may be watching. Gabby, we'll start with you because I got to pick someone.
Oh. Okay. So I know that it's tempting and everybody wants to do edge technology because they want to learn and that kind of stuff. But sometimes some companies' policies, if you work for a bank, you couldn't probably be running a Kubernetes relational database with PII and that kind of stuff, as your day-to-day business, because they have so many compliances to be attending to. So you should maybe, instead of running your own VM and then just say about Google, do Amazon, do Azure, whatever, like look at managed database offerings. It's gonna be like it's the sweet spot. I think it's like, it doesn't scale horizontally. It does help you scale vertically, but it kind of helps you with the cost management. And then we talked about like a scale by credit card, and like help you have point in time recovery, test your backups, like that boring operations that can be sometimes to set up all those things if you're setting up the container by yourself and that kind of stuff. So it kind of takes away that kind of difficulty. So just try to, if you're migrating from bare metal, do like step by step, migrate to a cloud VM, then cloud manage database, and then maybe go to Kubernetes, those step by step. They're just, don't buy all in, like just be careful, because data, it's our most important resource.
Deepti?
I'll give a slightly different take on this. It is scary to put your data into an infrastructure that you may be leery of. So certainly go to a managed provider and do your research and due diligence on what you can and cannot get out of the managed provider you are going to. So PlanetScale DB, for instance, is a database as a service, and we are confident in it because we are running Vitess, which has been in production for almost 10 years now. And that sort of a track record is what you should look for when you're going to a managed service.
Thank you. Andre?
I'm probably completely on the other side. I would say I'm a little bit more of a trying things out and see if it sticks, and more on the. I mean, our entire product was fairly experimental, so I got to play around with all of this stuff, and I would say that don't try to put everything right away. But I think that should be the goal, that we should be running everything open source. Managed DBs are cool, but I think it's nice to have a peace of mind of running your own stack in some sense. Also, it's all open source, so it's always fun to engage with the community there and exchange ideas and always find bugs and fix the bugs, and also try to push those databases in the direction that you want them to go, which I guess is being orchestrated by some in containers by some, maybe not Kubernetes, but by something else. I think this is kind of what, like, we can't stop the progress. We should be a little bit
cavalier,
cautious, but not, cautious, but try to improve it. Like, it's kind of on us right now to push it and improve it. Yeah.
Great, Yale.
Yeah, so I want to provide some different aspects. Actually, we've discussed so much about the pros and the cons about containerization and orchestration, but actually, to a software company like PingCap, the key is customers. If our customers feels good and comfortable about Kubernetes or containers, we cannot say no to them. We cannot say, oh, TiDB does not fit Kubernetes well, so you shouldn't run it in Kubernetes and you should build a operation team for VMs. No, we don't do this as developers. I think the general principle is to try our best to understand the traits of different infrastructures like Kubernetes, VMs, and containers, and make your database product much more seamlessly run on almost all of these infrastructures, because our mainstream customers uses various of them, and we have to support both of them well.
I'm your biggest cheerleader right now, man. That's such a good, powerful message. I love it. And then Tenix, wrap us up.
I think for as we think that databases is the core of the company, and so we must take care of it. For running distributed databases is already complicated, and if we run distributed database in Kubernetes, you should always think carefully about it. If you really understand, if you are using the open source part, you really need to understand every part of the technique under the hood. Otherwise, if you made a mistake, you will lose your most valuable data. So, to evaluate the technique, I think the best way is to do all kinds of testing. For some companies may not will not take a thorough test for their databases, and so when some serious issues happens, they don't know how to handle it. So companies should do disaster recovery drills from the beginning, so they can know what to do when this worst case happens. So that also can help evaluate the database technique.
Yeah, and I think you highlight something really, I think that's a great closing message is whenever you're doing anything in containers, think about the worst case scenario first instead of the best case scenario of what you get from the containers, because there's so much good that sometimes people forget what can happen if it does blow up. So with that, we are 5 minutes over. I am going to, the talk after this one is my talk. So I'm going to graciously give my time to my personal friend, Manjot, and his colleague, Tim. And they're actually going to segue really nicely and tell us how MariaDB uses Kubernetes to enable their database as a service offering in SkySQL. Soar sky high, Manjot. We're depending on you.
Thanks. I'll have to share my screen here.